Hi everybody, this video is going to go over the stoichiometry review pink and blue level questions. So to find molar mass, important thing you're going to have is your periodic table. So for the first question, we're trying to find the molar mass of methane. So we're going to look at carbon. There's 1, so we need that 12.01. Plus we have 4 hydrogens. Each one of those is 1.01. So you can either choose to do 1.01 plus 1.01 plus 1.01 plus 1.01, or just put this in parentheses and multiply it by 4. So when we actually add that up in our calculator, it would look something like this. Don't forget those parentheses. And your answer would be 16.05, and importantly, grams per a mole. All right, rubidium fluoride. So rubidium's mass is 85.47, and we're going to add 2 fluorine to that. So fluorine's mass is 19 times 2. And we get 123.47 grams per mole. Next up is lithium sulfate. So lithium is 6.94. There are 2 of them, so we multiply that by 2. Sulfate's kind of a tricky one. So there's 1 sulfur in sulfate, which is 32.07. But then there are 4 oxygens, so we have to do 4 times our 16 for oxygen. So in our calculator, 6.94 times 2 plus 32.07 plus 4 times 16. So remembering those parentheses is really important. Get 109.95 grams per mole. All right, and our last molar mass that we're finding today is aluminum nitrate. So there's 1 aluminum and there's 3 nitrates. So we're gonna have to do some math here. Well, not that we aren't already, but so we have 26.98 for our aluminum. There's only 1 of those. Then we have nitrates. So we're gonna have 3 times this whole value in parentheses. So be careful because there's 3 down here. So we have nitrogen, which is 14.01, and there's 1 of those in a nitrate, plus, in parentheses again, 3 oxygen, 3 times 16. It's going to be really important that you put that double parentheses at the end. All right, check out how I'm doing it in the calculator. 26.98 plus 3 times 14.01 plus, in parentheses again, 3 times 16. Close that parentheses, close the one before that, enter. So 213.01 grams per mole. All right, balancing the following equation. So first off, we can notice that there are 2 chlorine here and 2 sodium there, so we need a 2 up front here. We have 1 calcium here and 1 oxygen here, so that means everything else is balanced. So the next one we're looking at, we've got 2 sodium here, 2 fluorine here, so there needs to be a 2 here. We've got 1 oxygen, 1 oxygen, 1 magnesium, 1 magnesium, so everything else is 1. All right, last balancing equation. This one gets a little bit tricky because it does have many carbons. But if you remember from biology, hopefully you might, this is the equation for cellular respiration. So we have 6 carbon here, so we're going to need a 6 out here, which makes it that we have 12 oxygen. So to make 12 oxygen, we would need a 6 out here. And for these 12, you're going to need a 6 here for the hydrogen. And that gives us the 6 oxygen we need here. So it's pretty fancy. That was a quick balance. But if you really need to spend some time on that one, you could use a RAP chart. All right, blue level questions. So now we have 1-steppers. So let's see, we have how many grams are in 7.3 moles of water. So I always like to put down the number that's given to me, and that was 7.3 moles of water. And I know that I need to have that mole on the bottom to get rid of it. And that's going to be 1 mole of H2O. And on top is going to be my molar mass. If you are looking at a road map, like the mole road map, you would see that to go from moles to grams, you have to multiply by the molar mass. And the molar mass of water is 18 grams of water per 1 mole. So we do 7.3 times 18. It's going to give us 131.4 grams of water. So don't forget those units. Next question, how many grams are in 6.2 moles of CO2? So see, again, I'm writing out the number that was given. Moles again is going to be on the bottom, and grams is going to be on top. So 44 grams per 1 mole of CO2 gives me 6.2 times 44, 272.8 grams of CO2. How many grams are in 3.8 moles of lithium chloride? Same deal. For every 42.5 grams of lithium chloride, there's 1 mole. So we're going to do 3.8 times 42.5, which gives us 161.5 grams. So now if it was asking in the reverse order, so how many moles were in so many grams, then you would be dividing by the molar mass. All right, next question. How many moles of F2 are needed to produce 3.2 moles of HF? This is going to be one of our mole ratios. We're going from mole to mole. So mole of HF is going to go on the bottom, so it cancels out. Mole of F2 is going to be on top. Then we have to look at our balanced chemical equation. We look for the coefficients. F2 has a 1 in front of it. HF has a 2 in front of it. So we're going to take the number we were given, that 3.2, multiply by 1, and divide by 2. So we get 1.6 moles of F2 are needed to produce 3.2 moles of HF. Next question, how many moles of magnesium bromide are needed to produce 3.6 moles of magnesium chloride? Same deal, molar ratio. So moles of what was given on the bottom, magnesium chloride. Moles of what we want on top, magnesium bromide. Balanced chemical equation, magnesium bromide is 1, magnesium chloride is 1. So we just end up with the same because we're multiplying 3.6 by 1 and dividing by 1. So 3.6 moles of magnesium bromide. Last blue question. How many moles of O2 are needed to react with 12.5 moles of iron? Mole ratio again. So this time iron's going to be on the bottom. So 4 moles of iron for 3 moles of O2. So 12.5 times 3 divided by 4 gives us 9.375 moles of O2.